Hello, I'm Robert, and I'm from the Facebook group Doomsday Debunked, where we fact-check the stories that scare you. And this time, I'm talking about a story that has scared some people and has been shared in the group in the New York Times. It's called Opinion: How Scientists Got Climate Change So Wrong. And it is all about this usual thing that the newspapers are saying nowadays. They keep saying over and over and over, the scientists are being too conservative, they're not telling it how it is, everything's going to spiral way out of control, we're all going to extinct in 12 years or 5 years or 2 months. And it has gone way out of hand, and unless you kind of up the ante on the last journalist who said we're going to go extinct in 12 years, so we've got to say it's 18 months. And there was a recent one on BBC said we don't have 10 years, we only have 18 months. That was only a few months ago. So what they're going to think about in about 12 months from now. It was actually, I won't go into that one. Anyway, so this is another one of these that's scaring people, is with ridiculous exaggerations. And it spoils it for everyone, because the scientists are not saying that. So anyway, this is just riddled with mistakes, but it doesn't deserve going into all of them. It would take me hours and hours, because, like you say, over just that short sentence, I've written all that much, and it's only part of it. There's only that little bit. So they say methane-laden, they say here, in 1990, the Intergovernmental Panel on Climate Change, United Nations group of thousands of scientists representing 195 countries, said in its first report that climate change would arrive at a stately pace, that the methane-laden Arctic permafrost was not in danger of thawing, and that the Arctic ice sheets were stable, ... Well, the methane-laden Arctic permafrost, that immediately tells you that someone who doesn't really know what they're talking about, because there isn't any methane in the Arctic permafrost. It is organics laden. It's frozen vegetation and bodies of small animals and things from thousands and thousands of years ago. It's been frozen ever since. And when it thaws out, then that's when some of it might turn into methane, just in the same way that if you put some dead things in the bottom of a pond, then it'll start bubbling up bubbles of methane. But it would obviously be different if you buried it, say, in some nice dry soil. Then it would turn into compost. So some of this might just turn basically into compost and make the soil nice for first of all tundra, and then some bushes and trees. Some of it might decompose into carbon dioxide, some of it might turn into methane, and as it comes up to the surface, then turn into organics, and maybe all the methane gets eaten up before it gets to the top. And then it matters what happens after it. Like if it's got peat bog on top, then peat bog is constantly taking carbon dioxide out all the time, a small amount but steady. And if it's tree or bushes and so on, then they enrich the soil, they bring carbon dioxide out of the atmosphere constantly at a slow rate, and they also have carbon dioxide in the trees themselves. So it's very, very, very hard to predict. There's a whole wide range of different. You get papers coming up. Some papers come out saying there's going to be a big source of carbon dioxide. Some say it's going to be a big sink. But nobody actually knows. And unlike the other IPCC things like the climate, where the difficulty is getting a very, very high resolution because the weather is very sensitive to tiny details. And yet, if you get all the details right, then it mightn't make the whole picture mightn't work. You've got to make the details fit together to the whole thing, because you can't have a perfect model right down to the very, very tiny detail. If it's not really the solution to climate models to model everything to the nearest centimetre. If you could do that, you've got to make sure that what you're doing in the detail also fits the whole thing, and the whole thing works together. So you've got to do it at all scales, very large scale, very small scales, all working together. At the moment, there used to be quite a few kilometres per thing. They're just beginning to get sub-kilometre, which is why they can't model tornadoes. They simply can't make the climate models for the entire world detailed enough to tell you what's going to happen to tornadoes in the future, because each tornado will just fit within one grid block, so you obviously can't model it. And then they have these ways of modelling little detailed things and fitting them to big things, but that's quite difficult to get that working as well. So the climate modelling is it's really tricky, but it does work, because we use climate models to forecast the weather. And when the weather forecast says what's going to happen next week, they are using climate models. And the climate models, in the same way for the future, right into the forward future of the climate, then that's the same thing. And they have the same problems. And they have to work their way through this. It's a slightly different way it works, whether it's short scale or long scale, but it's the same thing. They don't model everything. They have these approximations, and they work out how to get these approximations to work for the whole climate. So that is the challenge with climate models. And they have these very well-tested climate models, which they've now tested we've got ice ages going back 2 million years. And you look at how the variation of the Earth's orbit, that is when it gets elliptical or round and so on, that's changing, and then the tilt of Earth's axis, how it moves around, and the various changes in Milankovitch cycles, and then the way it affects other parts of the Earth, the way it affects the warmth in the northern hemisphere, how that then leads to oscillations into the Southern Ocean, that then causes a release of carbon dioxide in the Southern Ocean, which then has a very, very slight and a very slight warming of the Southern Ocean right away. The warming of the Southern Ocean produces more water vapour, which produces a little bit more greenhouse gas, just from the water vapour and the carbon dioxide. Anyway, the whole thing's modelled from then on in great detail, and they put these climate models and they run them through the ice ages, and they track the ice ages when they actually happened in the models. So, and then they also use them they use them, for instance, to predict the effect of a volcano in late 1980s, I think it was, and it came out exactly as expected, and that helped validate that these things are actually working. And despite what people say, our climate right now is pretty much exactly tracking the models, the very early models from the 1970s. There's a good Carbon Brief article about that. It's completely untrue that the models were wrong. We're pretty exactly tracking them. But they're saying, this is all about saying these early models were wrong. So now look and say, they say this, they got the methane laden Arctic permafrost. They just got that wrong. They didn't know what that means. And then they said it was not in danger of thawing. They said the 1999 report said it was not in danger of thawing. So let's go and look at that report. And so I've got quotes there. And so I think that this author can't have looked at the report when they wrote that. I mean, there's no other answer to it. Either that or they're lying. Because you go to the report and there's this section, changes in permafrost distribution, and it goes and talks, and I have to magnify because I haven't got my glasses. Oh, get my glasses on. Under global warming of 1 degree C, the most significant changes within Russia proposed for the southernmost portions of the permafrost boundary with the climatic zone, and then it goes on and talks about significantly expand the area of relict permafrost. Boundary of the climatic zone will recede approximately the same distance, and the ground temperatures, and then the thickness of the active layer expected to increase by no more than half a metre, so a half metre thawing. And then this goes at 2 degrees C, you'd have nearly 1 metre thawing. So how does that mean? How can you surmise that as I'm saying it was not in danger of thawing? And there you are talking about the thawing. Maybe they don't know how to read scientific writing, and they don't know what an active layer is. And then further down, vulnerability. So I suppose it's possible that this journalist read this and just doesn't know what the words mean. That's also a possibility. And then they actually talk about they talk about vulnerability of human settlement to rapid thawing of the permafrost. How could you read that as being no danger of thawing? I mean, it's a complete mystery. Climate models have generally projected that the Arctic will more rapidly than the average global temperature increase. That's exactly what has happened. Such a rapid warming could result in a significant thawing of the permafrost in the subarctic, producing major disruption to buildings, roads and bridges, adversely affecting the stability of some existing structures and forcing changes in construction practice. And French, 1989. Because the IPCC do not do any research themselves, they are summarising the research of other people. So there, in 1990, they summarised the best research they could find, which was this author in 1989 who was warning about the effects of permafrost melting, thawing, and what that would do to our buildings. And we are getting that just now. We are getting, as they predicted, that the permafrost is thawing, and this is affecting our buildings. So, I mean, look at this journalist. How did they read that? They didn't even. They could have just done a search of a text search for the word thaw or something. I mean, honestly, it's atrocious. Absolutely atrocious. Let's look at what else they got wrong. Just sure. Right, so yeah, just this one. So then they said most likely a separate UN report said we headed for a much higher warming. Then the report they're giving there is from 2017, and the reason that it changed for 2000 and that was back then in 2017 people thought, oh, it'll be okay, we'll go for 2 degrees C, but it was particularly pushed by the more vulnerable nations, the ones that would be flooded in the Pacific, and they and some others, they pushed and they said, can we have an IPCC report for the difference between 1.5 C and 2? And before they made that report in 2018, the scientists didn't actually know. Nobody actually even tried to look to see if there was a difference and what the difference was. So they didn't actually know there would be a significant difference. And it was really, that was their main finding, that not that there's a tipping point, there isn't, but that even half a degree makes a significant difference. And particularly, very surprisingly, to the coals. That 2 degrees C, and 99% gone, 1.5 degrees C, significant amount of coal is still left, which means that the reefs can really colonise much more easily. So anyway, but another thing that they found going through to 2018 is that they found that our carbon budget for the future had been underestimated. And so when people say, oh, the IPCC are always conservative, up to 2018, they underestimated the remaining carbon dioxide budget that we had. So they made it too low. So they weren't being cautious enough. They heard the wrong way. So they go both ways because they just follow the science. That was what the research findings at the time. But we have refined it, and we found there's a bit more carbon budget. And that's why we can head for 1.5 degrees C by going to zero emissions by 2050. So, now what else? Yes, and they make a huge big thing about this. They talk about this view, 40 years of satellite images suggest the eastern Antarctic, which was thought to be relatively stable, may also be shedding vast amounts of ice. Shedding vast amounts of ice. You know how journalists use these words, emotive words. You can visualise the Arctic, the eastern Arctic, and all the ices are pouring off it, shedding vast amounts of ice. And if you visualise that, you imagine almost the entire East Arctic just sort of falling off, can't you, when you say that, when you read that sentence. Not that it could ever do that. But the paper they cite is just one of many, and nearly everyone was saying that it's accumulating ice, but this one goes and says it isn't. And then the journalists get a hold of it and they tell everyone, oh, look, the scientists have changed their mind. But this is just, these things, they have different ways of modelling and trying these things, and they slice it in different ways, and it's very difficult to actually get these were using, I think, photographs from the air. Yes, the paper they cite was using photographs from the air and interpretation by looking at them visually with eyes. And it was quite difficult to interpret the images. I think that was right. And then together with modelling. Anyway, whatever the reason, yes, it was a regional climate modelling, associated firm densification model as a key constraint for, I don't know what all that means, it's all very techy, I haven't tried to find out. But anyway, the density conversion is only exactly correct in ideal conditions, which obviously deviates from the actual in many areas, and especially in the marginal areas. And so this introduces some uncertainty to the estimation of ice sheet mass balance. So anyway, they looked at all that along with dozens and dozens of sites. This was just one of many, but I picked up that one to find it. I found this as a citation of that. And the journalists could have done that as well. Pop that into Google Scholar, look for the sites of it, look for a more recent review, and see if modern scientists are still saying what they said back then, just a short while ago. Because this is very much in flux. And then they came to the conclusion, after looking into that, it was quite a high-level review kind of article, looking at lots and lots of different things, and as well as and they said, and they came to the conclusion over the period, the entire change in mass by minus the entire area by minus 84, but so it was losing mass as you expect. Western Antarctica minus 69, Eastern Antarctica 12, plus minus 16. So it's just possible it was losing a little bit, but most likely it's gained quite a bit. And the Antarctic Peninsula lost minus 27. So the Antarctic Peninsula and West Antarctica, as expected, are the ones losing ice. And although there's still quite a bit of uncertainty, then it does look as if East Antarctica is pretty likely that it's still gaining ice. And that's the entire Eastern Antarctica. The central higher bits of Eastern Antarctica will be gaining ice all the time because snow is constantly falling there. But that's including all the way right down to the coast. And it seems that that is also still gaining ice on the whole. So that is just, I just picked out a few salient points from this article, and I haven't bothered going through. As I went through it, I spotted several really awful errors, and I'm not going to go through debunking them all. It's not worth it. It doesn't deserve that amount of attention. But I thought I'd just alert you to that this is not a valid argument, a valid paper. It is atrocious, especially saying that bit about thawing when they just need to have looked at it. And this about the Arctic sea ice, just picking out one paper and not looking at what at the other papers that cite it to see what they say about it. I mean, goodness me.